In order to create tunnels, civil engineers devise plans where tunnel boring machines begin drilling at both ends of the tunnel and meet somewhere in between. Is this real, or are we suspending reality?
It's probably real.
It's probably real, okay? It's probably real. A tunnel is being built through a section of mountain. One tunnel boring machine alone can finish the tunnel in 4 years. Another machine can finish the job in 3 years. If both machines start at opposite ends and work at the same time, when will the tunnel be finished?
Between 4 and 3 years.
You think so?
3 and 4 years.
You think it'll be in between 3 and 4 years?
Yes.
Anybody else have a guess?
I like that guess.
You like that guess?
3, 4, maybe in between 3 and 4 years or less.
So if they're working at the same time, it's going to take them together longer than one of them takes by themselves?
Well, like if it takes a year for like to then, if it takes a year to like get a quarter into the
I'm with you.
and then the other one goes and that's like in a year that it's already like halfway done in 1 full year.
So, but
2 years.
you're agreeing with her by saying that it's going to be between 3 and 4 years. Is that what you meant?
Something like that. I don't know. I'm lost now. I think I confused myself.
You guys do that a lot. You confuse yourselves a lot. I'm not trying to help you confuse yourself. I'm trying to get you to think about it.
Well, what just happened? It went from paper to pink.
Mm-hmm. Anybody else have any other guesses?
So wouldn't it depend on how long or how much tunnel they have to dig?
Well, not so much, just because it doesn't depend on how much tunnel they have to dig, because I'm just telling you right now, maybe like in the past, in a similar mountain, I don't know. Now I think we're suspending reality. You know what I'm saying?
Yeah.
So, but we're saying we know for a fact that if one of these machines worked by itself, it would take 4 years to finish this part of the job. Okay? Another machine by itself works faster and can do it only in 3 years. Okay? So how long would it take together? Did anybody think the answer would be 7 years?
If you added them together.
If you added them together. That's where it came from, right? If two machines are working together and one takes 4 years and one takes 3 years and they're working at opposite ends and heading toward each other, is it going to take 7 years?
No.
No. Not even close, right? Okay? So good. I'm glad you didn't think that. Okay? So we've already talked to people who thought it may be between 3 and 4 years, and then we've already talked to people who thought it would be less than 3 years, because if they're working together, it should take less than one by itself. Right? So let's see if we can figure it out. Okay? So we're gonna write some words the first time we do this problem, so you can get an idea of where these equations that we're using are coming from. Okay? So first of all, we're going to say we're going to let x equal, you can't see that, we're going to let x equal the number of years together. Okay? The number of years that it takes when they work together. You okay with that? Okay. How many jobs is this? It's really one job, isn't it? The job is to bore through the mountain. Okay? But we have two different machines, right? So we have one job that takes one of the machines 4 years. We're not always going to write words, just so you know. Just kind of trying to help you get a way to think about this stuff. Okay? And what else do we have?
One job.
One job,
3 years.
3 years. Oh, it has to be equal something, doesn't it? Because we're trying to figure it out. What's it going to equal?
2 and 7.
We're still having one job, right? But this time both machines are working together. Do you see how that's still one job? Okay? One job over what? Yeah, x. Because that's what we're trying to figure out, the number of years that it takes them when they work together. Okay? So this is what the problem actually looks like. 1/4 plus 1/3 equals 1 over x. Oh my goodness, that looks like the problems we did yesterday. Let's find a common denominator. What do you think our common denominator should be? 12x, right? Remember, we have to take all the factors that are in the bottom somehow and get them together. This has factors, of 4, this has factors of 3, and that has factors of x. So all together we get 12x, right? We're going to multiply everything by 12x, everything by 12x, and everything by 12x. Have I changed the value of the function if I multiply every single thing by the same thing? No, it's still the same value, right? What is this going to do for us? Do you remember from yesterday? What is this going to do for us? Get rid of the fractions, yeah, the denominators. Okay? So simplify the 12 and the 4. What do we end up with? This is a 3, that's a 1. That's what we wanted, right? We wanted a 1 in the denominator. So we end up with 3x. Simplify the 12 and the 3. What do we end up with? This is a 4, that's a 1, so we get 4x. Wait, what do we do at the end? Cancel out the x's, good. Because they simplified to 1, right? Equals 12. All right? Does anybody happen to know what 3x plus 4x is? 7x?
Sorry.
It's okay. 7x equals 12?
Divide by 7.
Very good. Divide by 7. X equals?
12 over 7.
If we say 12 over 7, first of all, is that an acceptable answer?
Yes.
Yes. It always has been, right? Why would it change now? Okay? Does that really tell us what we need to know right now?
You know what does mean?
Not really, right? So, hey, I need to show you guys something because I showed another class it, and they were astounded. Like I had just done some really amazing thing. Okay? So watch. 12, if I say 12 divided by 7, the calculator's a smart aleck and tells me, oh, it's 12 over 7. Thank you, smart aleck calculator. Okay? So instead, if I do 12 divided by 7, and before I hit enter, if I hit the control button, control enter, it goes straight to a decimal. Okay? Now, yeah, you can do menu and convert to a decimal and everything like that. That totally works. But my way's faster, right? Okay? Oh, okay, just put a decimal at the end. That does it too? Okay? All right, that's another way. Good, thank you for telling me that. I didn't know that. Okay? So while 12/7 is a perfectly acceptable answer, that doesn't make much sense to us as far as time goes, does it? So it might be a good idea to put or 1 point, what did we say, 7? That's rounded, right? That's not exactly it, but that's approximately it. And it's 1.7 what? Years, right? Does that make more sense to us? 1.7 years? Okay, so this crazy kid said, oh, so they finished in August. I was like, August? And he was like, yeah, January, February, March, April, May, June, July, August. And I was like, first of all, August is 8. July would be 7. Okay? But does 0.7 mean July?
No.
It's just a 7.
It's 0.7 of a year, not months, right? Are we okay with that? Okay, good. So, the next thing I need you to think about is that answer make sense? The mathematical language, the language of the teach say, is this a reasonable answer? Does it make sense in the context of the problem? You guys said to me earlier, you're pretty sure it wasn't 7. We were pretty sure the answer was not between 3 and 4. You thought it would be less than 3. Just like predicting before we even started the problem, right? Is that less than 3?
Yes.
Yeah. Some of you even said around 2, right? Well, is that around 2?
Pretty close.
Yeah.
0.3.
So is that a reasonable answer? Absolutely. Okay, any questions? We good? Tobias drives 300 kilometers in the same time that Alicia drives 200 kilometers. The speed at which Tobias is driving is 20 kilometers more than the speed at which Alicia is driving. Find the speed at which Tobias is driving and the speed at which Alicia is driving. Okay? Where in the world do we start?
Well, we could start the same. Just do like x equals the number of miles to get numbers.
Do you think it might look like the previous problem? A little bit? It doesn't exactly. Okay, it doesn't exactly. Let's write down what we know. Can we do that? Okay, Tobias drives how far? He drives 300 kilometers. What else do we know? Alicia drives 200 kilometers. What's important about that information, besides the fact that it tells us, like, how far they drive? They drive it in the same amount of time. Do you guys know any formula that's just like stuck in the back of your head about a distance and a time?
Speed equals distance divided by time? Or something?
The most common one that people know is this one. Distance equals rate times time, right? Yes? Okay. If we know that it takes them the same amount of time to drive this, watch what happens if I divide both sides by r. T equals d over r, which means the distance divided by the rate should equal the time. Okay? So if we were talking about Tobias's distance and rate and Alicia's distance and rate, what would be true about those two values?
They should equal the same time.
They should equal the same time, which means they should equal each other. Okay? So let's make a column right here about Tobias and a column about Alicia. Do we know Tobias's distance? What is Tobias's distance? 300. Do we know Alicia's distance? It's 200, right? What do we have left to know? The rate. Okay? How fast did Tobias drive?
20 more than she did.
20 more than she did. So if we're basing his speed on hers, what do we have to call hers? X. Very good. If we call hers X and we know he drove 20 kilometers per hour faster, then what is his? X plus 20. Very good. How do we solve this kind of equation?
Cross multiply?
Yes. Again, this is the only time we can cross multiply, right? Okay, two fractions set equal to each other. So I multiply these two.
Or 300x.
300x equals,
200.
I don't want to go too fast. Let's just write down the steps. Okay? Write down the steps. If you guys can skip some steps later on, that's fine with me. You know it is. Okay? What do we do with the 200 times x plus 20? Good. Distribute here and here. So I have 300x equals 200x plus 4,000. And now?
Subtract 200x.
Subtract 200x. So 100x equals 4,000. And now to solve for x, Divide by 100. X equals 40. Yes? What does that mean? Whose? That's Alicia's speed, right? Is that what my answer is? Am I supposed to find out what Alicia's speed is?
That's one of the answers, yes.
Oh, that's only part, right? That's only one of the answers. So what my question asked me to do is find the speed at which each one of them are driving, right? So I can say Alicia is driving, I can't spell today, Drivin, driving 40 kilometers per hour, and Tobias is driving
60.
why 60?
Because you're adding 20 to it.
Perfect. 60 kilometers per hour. Yes? Any questions about this? Feeling good so far? So let's talk about 4. No, I know 3 comes next after 1 and 2. I just want to talk about 4. Okay? If you want to, we can go back and do number 3 before you start working on the other part. That's fine with me. But I really want to talk about 4. One pipe can fill a tank in 6 hours, while another pipe can empty it in 2 hours. If both pipes are open at once, how long will it take to empty the full tank?
What?
What do you think this is? This going to look more like 1 or more like 2?
2.
1.
Why do you say it's going to look more like 1?
Because it gave you one job. It gave you like 2 different things.
It's
that had
basically like one job, right?
to have the same job.
Except this time it's different. What's different?
There's only one thing doing
Are
it.
they working together?
No. Wait.
How are they working? One's filling it and one's emptying. So they're working against each other, aren't they? How's that going to affect our equation?
Making one negative and making the other positive.
Absolutely. Absolutely. One of them is going to have to be negative. Okay? Which one do you think is going to have to be negative?
The one that's empty.
Probably the one that's emptying, right? The one that's going to be negative is the one that's going to take the less amount of time. Okay? The one that takes longer is going to need to be the positive number. Okay? So we have to figure that out. We have one job that takes 6 hours, and we have one job that takes 2 hours. Right? So which one of those is going to have to be the negative? Which one takes more time? Which one's the bigger number? 1/2 or 1/6?
1/2.
1/2 is the bigger number. So that is going to be the negative. Okay? Otherwise, if we're not careful, we'll end up with a negative number for our answer, and we know that can't happen because we're asking about a time. Okay? What's this going to equal? 1 over x, because we're figuring out how long it takes for them to work against each other. So I have to know a common denominator. What would be my common denominator? 12x would work, but 6x would also work, wouldn't it? Again, 12x would work, but 6x would give us smaller numbers we have to work with, right? Which one do you want me to do, 12x or 6x?
6x.
6x, okay. So if I multiply each term by 6x, what happens?
The 6 cancels.
6 cancels and I end up with negative x.
3.
The 6 and the 3 simplify, the 6 and the 2 simplify to be 3x.
And then the x's cancel out.
X's cancel and we get 6. What's negative x plus 3x? 2x equals 6.
X equals 3.
X equals 3. X equals 3 what?
Hours.
It will take 3 hours to empty the tank. Questions? You want to do the cupcake one?
Sure.
You don't know what that means. Number 3 is about cupcakes. You want to do that one? Yes? Okay. If you have a choice to work with fractions or without fractions, what would you probably choose?
Without fractions.
Without. Okay, so keep that in mind when we start working on this. Okay. Chef Craig, thank you. Chef Craig can decorate a dozen cupcakes in half the time of Chef Charlotte. Together they can decorate the dozen cupcakes in 8 minutes. How long would it take each chef to decorate a dozen cupcakes alone? So is this going to look more like number 1 or number 2?
Number 2.
Dose.
How many jobs do we have?
We have 1 job.
We have 1 job. So it's going to look like number 1 again.
Is it?
Mm-hmm.
Really?
Mm-hmm.
So
The difference this time is when we looked at the first problem, we knew how much the first machine took and how much the second machine took, and we wanted to know how long it took together. This time, we know how long it takes together. We want to know how much time it takes separately. You see what I'm saying? So we know it's going to look something like this, right? And they are working together, so it is going to be plus. We've got 1 job. We've got also 1 job. We still have 1 job that takes 8 minutes. Okay? This is about Craig. This is about Charlotte. It tells us in the first sentence what our variables need to be in the denominators. Chef Craig can decorate a dozen cupcakes in half the time as Charlotte. If we make Charlotte X, what is Craig?
1 half.
Half X, right? You told me a second ago we don't want fractions.
5.
Would that way work? Could we make Charlotte X and Craig be a half X?
Yes.
Absolutely. Okay, absolutely. But that puts a fraction in the denominator of our fraction, which you told me a second ago you don't want to do, right? So what if we made Craig X? What would Charlotte be? 2X. Is that okay? Okay, can we do that? So here's Craig and here's Charlotte. What do we have to do?
find common denominator.
What would be our common denominator? 8x. 8x there, 8x there, 8x there. Tell me what happens.
X is
X is simplified to 1. We get 8.
X.
X is simplified to 1.
And we
And the 8 and the 2 simplify to 4.
What do equals X?
8 simplify and we get x. Oh my gosh, look how easy this problem is. Does anyone know what 8 plus 4 is?
19.
Oh my gosh. 19 equals x.
Why'd you put 12?
Because 8 plus 4 is 12.
Oh.
I was
Sorry.
just teasing her. Because she said 19.
I was messing around.
Yeah,
It's like that.
she was messing around. So answer the question now. We've answered the equation. Answer the question.
12 minutes.
It takes both of them.
It takes Craig. Craig was x in our problem, right? So it takes Craig 12 minutes. And it takes Charlotte what you got? 24 minutes.
Really slow.
She is slow.
I wonder if
Maybe she's just a perfectionist. To make a dozen cupcakes. Decorate. It's really decorate, not make. Sorry. I wrote make. Okay, do you have any questions about this? So you have the rest of the period to do the other 4. Okay, the other page called Applications of Rational Functions. You have the rest of the period to do this. I will be checking these 4 when you get to class tomorrow. Right? If you have any questions, please come and ask. Peace.